All right,
I
thank
can
you.
see.
Thanks. Okay, so today we're going to be talking about the Stanford Math Tournament for a Logistem Math Division workshop. My name is Kevin Chen, and I'm a freshman at Ridge High School in New Jersey. As a new lecturer in Logistem, it's my great honor and pleasure to talk about the SMT for the organization. Do you like Stanford University? It's a well-known university to everyone. You probably heard it sometime in your life. Do you like math? Since you're in this meeting, I believe you do have an interest in math and would like to learn about the Stanford Math Tournament. Do you like tournaments? It's a great experience for you to meet your friends and new people and stay in a competitive environment that's friendly to everyone. If you answered yes to any of those previous questions, please consider participating in the Stanford Math Tournament. So, the SMT is an annual math competition that's run by students from Stanford University. It was established in 1999, and last year in 2024, I was surprised to know this, but there are over 2,300 participants last year. The purpose of the SMT and the goal of their team is to challenge and inspire middle school and high school students and math enthusiasts. So, the SMT is open to all students in high school and below, and no formal requirements for math skill level, but it's better to be familiar with problem-solving techniques because it's a math competition after all. Teams usually consist of up to 6 members in person or up to 8 people and a team online. And teams can be formed by schools or independent groups. So, for example, if you have some friends from across the globe, you can still be the same team, be part of the same team. And one little tip is that you should try to maximize the number of people in your team because, as I will talk about later, the individual portion of the team's overall score is basically summing up all of the individual scores. So it's not taking the average of the individual members' scores. It's a sum the individual members' scores. So if you have more people, despite even having like one or two really strong members on the team, having more members on the team is beneficial for your team's overall score if you want to earn a ranking in the top 10 or some other ranking in the SMT. So here's the competition structure. There are 3 team rounds. One of them is the power round and the other one is called the team round. And both of them are in the morning of the SMT. There's the individual rounds and the guts round that are in the afternoon of the SMT. Here is the test information, and this is from the SMT website. So as I mentioned previously, there's the power round, team round, individual rounds, and the guts round. A summary of all of them is that the power round is a proof-based round. The team round is a short answer round. The individual round, you have a lot of options to choose from, as I will explain later in the presentation. And the guts round is a really exciting round that has a live scoreboard. And these rounds all have different percentages of the team's overall score, and they have different durations. So first we have the power round. It takes 30% of the team's overall score. It's an 80-minute proof-based exam, and it's a focus on a single subject matter. So as you can see in this slide, basically, this slide is just from the 2024 SMT Power Round. And they first kind of teach you and introduce you to a topic in higher math, and they give you problems that you can attempt to solve. And this is often different from other competitive math problem sets because it's kind of introducing you to the topic first rather than just giving you a problem set to do the problems. And teams collaborate to solve the problems. So since it's a team competition, right? The team has to collaborate and see who should do which section or which problems. So you probably need to like practice your team synergy before the competition, like in the team round. This is a 50-minute collaborative exam, and it consists of 15 short answer questions. It's 20% of the team's overall score. And again, it emphasizes teamwork, strategy, and efficient problem solving across various mathematical topics, as the team round covers topics such as algebra, number theory, combinatorics, and geometry. Here are the first 3 problems of a team round, the 2023 team round of the SMT. The problems are short answer, and it's really similar to the Amy if y'all are familiar with the Amy's format, because it's also 15 questions and it's short answer. And a huge portion of the team's overall score is also based on the individual rounds. Despite being like each person's own contribution to the team, they have to be summed together to be a part of the team's overall score. For each individual, there are 2 options that you could take. The first option is that you could take the general test. It's a 110-minute exam with 25 short answer questions. It may seem like it has a lot of questions and it takes a very long time to do, but it's actually designed for students with less specialized mathematical backgrounds because, for example, if it's your first year of the SMT, you should take the general test, most likely, because you can kind of get a feel of how the problems are designed. The second option, however, is taking 2 tests, and those 2 tests are subject tests. And each test is 50 minutes and has 10 short answer questions. There's 4 subject tests to choose from: the algebra, the calculus round, the discrete round, and geometry round. So you may ask, since the 2 subject tests add up to 20 questions, is it more beneficial to take the general test to contribute to your team's overall score? Well, since the general test is easier, however much you score on the general test, it's multiplied by 60% to balance out the scores in the general test and subject test. So for example, if someone got a 25 on the general test, that only counts as a 15. So that's less than someone who gets 2 8s on the algebra and calculus rounds, for example. And the individual rounds are meant to measure individual problem-solving skills and mathematical knowledge. And the final round of after the individual round is the individual tiebreaker. And that's just to break ties between contestants with the same score on the individual rounds. And it's a 15-minute exam with 3 problems in the subject area. So for example, if you took the general test, which is option 1, it will give you 3 questions that can be any subject. So it could be algebra, discrete, or geometry, or algebra, calculus, geometry. But the subject tests, if you took them, the specific tiebreakers will also be the same exact subject as the subject tests. So if you took the algebra individual round and also the discrete individual round, you're gonna get the algebra tiebreaker and the discrete tiebreaker. And everyone who participates in the SMT has to do the tiebreaker because it's not only like the top 10 people who do the tiebreaker, because they grade the SMT and look at the results after the day you take it, because the award ceremony is the week after the actual competition. And it's also a great experience to have to solve problems. And the final round of the day is the guts round. It's 20% of the team's overall score, just like the team round. But in my opinion, this is like the funnest round of all of these rounds because 1, it is a team round, and 2, it's a fast-paced exam, and 3, it really focuses on team decision making because it's 9 sets of 3 questions, and you have a time limit of 80 minutes. So for example, if you solve the first set, you can go on to the second set. But if you don't solve and turn in or submit the first set, you can't get access to the second set. So that's why it really focuses on team decision making, because just say you have someone who can solve some problem of the first set, but your team thinks that they should move on to the second set to have more time to focus on the problems of the second set, because the later sets have more points. So that's why you have to really collaborate with the team, and this round requires speed, accuracy, as well as strong teamwork under pressure. Now, the SMT you can take in person or online. The in person is in the in the Stanford campus, and online you can go on the Discord or Zoom of the Stanford Math Tournament. And whether you want to go to the in-person competition or online competition, it's completely your pick. So that's what I like about the SMT. So if you don't have the time to go to the in-person competition, or if you're too far away from Stanford, you can always just go to the online competition. Now, here's an overview of the SMT in person, taken from the statistics and also the information for the 2025 SMT. It's on April 11th to 12th of 2025. It's for high school students in the US, and the cost is $20 per student, but financial aid is available. The location is obviously at Stanford University, and the size of a team can be 5 or 6 students. Around 800 students can be invited to go to the in-person SMT because they don't have enough spots for just say 1,000 students to participate. Here's the application and registration timeline for the in-person SMT for 2025. So as you can see, applications already opened in December of 2024, and the March dates are all like the deadlines for the in-person SMT. And the social activities are the day before the tournament, and the tournament day is April 12th. I see in the chat, Grace asked how teams are formed. Teams are formed, you can just register from a school or an independent organization. So if you register, you have to register at comp.mt. And in there, you can sign up yourself and then create an independent team or an organization for your friends or classmates to join your team. I hope that answers your question, but we will have like a whole Q&A at the end of the presentation. So I'm assuming that question is answered. All right, you're welcome. It's a pleasure. So the SMT Online 2025 is quite different. It's on April 13th of 2025, and all the students worldwide in high school and below can participate. So I'm assuming some of you are in middle school, so you should probably participate in the SMT Online. The cost is $15 to $25 per student. And the size of a team can be 6 to 8 students. And as I said before, I suggest having a full team of 8 students. And the award ceremony is 1 week after the competition date. And that date is April 20th of 2025. Here's the registration timeline for the SMT Online 2025. So as you can see, the registration opened in February. And the March and April dates, March 31st is the regular deadline, and April 6th and April 9th are the late registration deadline and very late registration deadlines. And nearing the competition day, the puzzle hunt, which is just a fun activity, is on April 12th, and then on April 13th is the actual tournament. And again, the award ceremony is 1 week after the competition day. Okay, but since the SMT online is online, How does the SMT team work to prevent cheating? Well, this year they proposed anti-cheating measures, and I got this from their website. So you can read over this. But just an overview, you have to be separated into Zoom breakout rooms and you have to share your screen, submit your scratch paper, and also the SMT team will work to review after the tournament to see if some students and teams should be flagged for suspicious behavior. Now it's time for the fun part, the sample problems. The first problem we're gonna look at here is the team round problem 7 from 2023. Um, if you don't want to look at the sample problems and their solutions, you should just stick around because I'll provide the useful links and also a Q&A session after I talk about these problems for people who are interested. So just stop sharing and I'll share like a whiteboard where I can write the solutions. Can everyone see my screen clearly? Is anyone having trouble seeing my screen? I just like unshared my screen and shared it again so I could switch to the whiteboard. Okay, is everyone hearing me correctly?
I can hear you. I can see your screen.
Thank you. Okay, I'll just talk about this problem now. So, I mean, if you had experience in the AMC series, such as the AMC 10, AMC 8, AMC 12, or the AMI, you probably have some experience to solve like competition math problems. And I chose this problem as our first problem because it holds a meaning. Because when I did this, it looked really daunting because there are 3 summation symbols inside a square root. But you can kind of look at this summation in here, right? You take it out. Summation, it looks pretty daunting, like the notation, but after all, it is just notation, right? So if you write this out, it's 1 over 1 plus k because the first j is 1. So 1 plus k to the negative 1 is just 1 over 1 plus k. And then you have 1 over 1 plus k, and then all of this to the power of 2. Because when j is 2, it's 1 plus k to the power of negative 2. And so on, 1 over 1 plus k to the power of 3. And then since the upper part of this summation is infinity, this is an infinite geometric series. And then, as you may have learned before, the formula for an infinite geometric series is the first term in the numerator divided by 1 minus the common ratio. In this case, the common ratio is just 1 over 1 plus k, because the second term, for example, is 1 over 1 plus k squared, divided by the first term, which is 1 over 1 plus k, we get 1 over 1 plus k. And that's how you get the common ratio. And if you simplify this, if you multiply by 1 plus k on the numerator and denominator like this, you get 1 over 1 plus k and then minus 1, which is just 1 over k. So what this means is that this summation over here is just equal to 1 over k. Sorry. Um, okay, so once you get this inner summation, you can tackle this summation. So tackle this summation over here. So because this part we just calculated, that's equal to 1 over k, right? So what we have to compute now for this part is the summation from k equals 1 to infinity of 1 over k. And this is just Basel's problem if you want to search that up. It's basically saying that the sum of all the positive integers from k equals 1 to infinity of 1 over k has to equal to pi squared over 6. So yeah, you could just search up Basel's problem and that gives you the conclusion. So once you get this conclusion, you have addressed this part of the summation. So now you want to address the part which contains the summation from t equals 1 to infinity. So you know this is just pi squared over 6. So this summation with t is summation from t equals 1 to infinity of 1 plus pi squared over 6, the whole thing to the power of negative t. So again, similar to the first summation, like the inner summation over here, it's a geometric series, an infinite geometric series again. Because the first term is 1 over 1 plus pi squared over 6. Second term is 1 over 1 plus pi squared over 6 squared. The third term is 1 over 1 plus pi squared over 6 cubed plus dot dot dot. And again, the formula for an infinite geometric series is the first term over 1 minus the common ratio. And in this case, the common ratio is the same as the first term, which is 1 over 1 plus pi squared over 6. And then similar to what we did in the beginning for the inner summation, we can multiply the numerator by 1 plus pi squared over 6 and multiply by the denominator by 1 plus pi squared over 6. Now, the numerator becomes 1 and the denominator becomes 1 plus pi squared over 6 minus 1, which is just 1 over pi squared over 6, which is 6 over pi squared. So, just looking at the whole picture here, this part is just 6 over pi squared, which means that this part over here, this whole part is 6 over pi squared. So now we have arrived at the square root of 6 times 6 over pi squared. And that is just the square root of 6 squared over pi squared. And that's 6 over pi, which is our final answer. I hope you learned something from this problem. If not, I hope you had fun solving it along with me. So along to the second question and the last question I prepared, which is the 2023 Guts Round Problem 9. And I'll just screenshot it over to Microsoft Whiteboard again. And here's the problem. 5 circles of radius 1 are stored in a box of base length 5 as in the following diagram. How far above the base of the box are the upper circles touching the sides of the box? So basically what the problem's asking for is the distance. So the upper circles are basically these 2 circles right here. So what they want is the distance from this point, which is clearly the closest point to the bottom of the box, to the bottom of the box, the perpendicular distance from here to this line. So what we want, so basically in circle problems, we usually want to connect the centers of the circle to find lengths. So since the radius is 1 for all 5 circles, this length is 1 plus 1, which is 2. And then since the side length of the box is 5 and the radii, okay, so the radius, so both side lengths are 5. And since the radii of the 5 circles are 1, this distance is 1. And this distance is 1. So therefore, this distance in the middle here is 5 minus 1 minus 1, so it's 3. And so this part of this right triangle, we want to find this bolded part. It's just 3 over 2 because since this part is 3, half of it is 3 over 2. So here it is 3 over 2. And what we are left to find is this leg of this right triangle over here. Since the hypotenuse is 2 and the one of the legs is 3 over 2, we can just do 2 squared minus 3 over 2 squared using the Pythagorean theorem and taking the square root, and that's what this side is equal to. And after expanding the squares, we get 4 minus 9 over 4 inside. And then we get 16 minus 9 over 4, which is just the square root of 7 over 4. And if you simplify that, we get root 7 over 2. We rationalize the denominator. So now we're basically done with the problem because, again, we want to find this distance, right? Okay, yeah, we want to find that distance. So now, oh yeah, so basically this is 3 over 2. Okay, so the summary of what we did here. So this is 2, this is 3 over 2, and then here, this distance over here is root 7 over 2, and this is 2. So what we want to find is the distance from, yeah, this is 7 over 2, so this is 7 over 2, because this distance, well, yeah, so this is root 7 over 2, and then, yeah, so because by symmetry, the point of tangency over here, so therefore, the answer, okay, I'll just draw with another color because I'm kind of getting confused right here. Just copy the diagram again, my bad. Okay, yeah, just to get organized. So this part, this radius is 1, and so this part is 2, and we got this part is root 7 over 2. And and this is 3 over. Oh yeah, because by symmetry, I think I kind of misread the problem. Yeah, because the distance from this circle over here, by symmetry, this is √7/2, and this is √7/2, and this radius is 1. So the total distance is 1 plus √7, because we were trying to find the distance from here to here, and not the distance from here to here. All right. Does anyone have any questions, or should I move on? Guessing no one has any questions. Oh yeah, just to summarize this problem. So what we learned from this problem is basically for circles, we want to connect the radii, I mean the center of the circle. So we can use the fact that the radii are equal to 1 to get more length. So we can use the Pythagorean theorem, find the length. So we want to find the distance from the tangent point to the bottom. So that's why that's why we're inspired to find this length, because this part is just the radius 1. So basically from this problem, we just want to connect the centers of the circle and then use the fact that we already know the radius of both circles. And then we also know the side length of the box. So we know that this distance is √7/2. So that's how we're inspired to get the final answer. It seems like CC raised their hand. So if you have a question.
Yeah, and the question is how far above the base of the box? Is that the answer should be square
Uh,
7?
because basically, wait, sorry, because the diagram is like, I'll just copy another diagram over. Because the question here, wait, copy the question. The question here is basically how far above the base of the box. So the base of the box is this section over here,
Yeah,
right? So the
but that means that how far the upper ball,
the upper
uh,
circles,
yeah, going up
because when
means
it's touching the sides of the box over
yeah,
here,
yeah, yeah.
yeah.
So
So
should we get the uh, I mean, should we consider the lowest point of the upper ball?
yeah, we
Yeah,
could consider
that
that.
point. Yeah,
Yeah, that's how I like read it at first, right? But I think I kind of misread it because like I get what you're saying here because I also like agree with you. But because I'm guessing since like first if we have like the distance, wait, if we have like the tangent to this part, because it says the upper circles touching the sides of the box, right? So I think that's like the hint for us to draw like this distance rather than this distance over here.
but I guess it's not emphasize the point of touching the size of the box. It's just asking how far, I mean, how high is the ball?
Yeah, probably.
And this is kind of confusing.
Yeah. But the problem's answer turns out to be 1 plus √7. So I'm assuming that this is the correct interpretation. But if we were to use this interpretation, right, we could just,
Yeah.
since this radius is 1, the answer is just 1 plus √7 and subtract 1 and we get
Yeah.
√7. So the answer is quite immediate from the key is to get the distance, which is √7/2.
All right. All right. Thank you.
Thanks for the question. Does anyone have any more questions? Okay, so let's go back to the slideshow now. Okay, so we just look at this problem, and prior to this problem, we looked at this problem. So just a Q&A, just to remind you of what we talked about, because I feel like also here are the useful links, but I feel like for this presentation, the most important part is still like understanding the format, the overview. It's basically just an overview of the SMT. I feel like the problems are just to get a feel of how hard the SMT is and what the problem format is supposed to be. So let's just go through the whole slides again. We talked about like what the SMT really is, and then who could attend, the structure of the competition, which is all these slides. And then we also talked about how it's in person or it could be online, and also the application and registration timelines, and how SMT is preventing cheating this year. And yeah, of course, we talked about the problems. So does anyone have any questions for me to answer?
Hey, I have a question.
Yeah.
How do you describe the difficulty level of this test? Do you think it's similar to like AMC 10, or it's kind of AMY level, or between AMY and JMO?
We can surely talk about this. So, hold up. I'm going to go to the SMT website to show you something. So, from my experience last year on the 2024 SMT online, I mean, the SMT in person and online have the same exact questions, but from my experience, basically, hold up. Yeah, so from my experience, so if we click into the general round, right? Because just say the individual rounds, because if you want to compare it to like AMC's or Amy's, you should look at the individual competitions, because AMC's and Amy's are individual competitions. So if you want to compare it to those, we can look at the general round. So it's suggested for beginners or like more like first year SMT participants to take a look at the general round and sign up for the general round to just get a feel of all the question types. Because looking through this document, it's 25 questions, which is really similar to the AMC 10 and 12. And the scoring system is different from the AMC 10 and 12 though, because the scoring system for this is basically like the AMC 8 scoring system, where you get 1 point for answering each question correctly and no points for answering them incorrectly. But what's different from the AMC's for the SMT general round is that you don't get the multiple choice answers. You have to provide a short answer. So the difficulty of these questions is probably around like the AMC 10 to harder AMC 12. For example, if we look at the first question, this first question is definitely harder than like most AMC 10s and 12s. I'd say like the first 10 questions are definitely harder than AMC 10s and 12s, but the questions in the middle are like similar difficulty. And then in the end, it's also similar difficulty. And also if we look at if you're more experienced, if it's your second or third year at the SMT, you're definitely encouraged to take the subject tests, for example, the algebra test. Click into it, it's 10 questions, it's 15 minutes. So it's slightly harder than the AMY, but if you're good at like the mid-AMY questions, this shouldn't be that big of a problem for you. I hope that answers your question.
Yes, thank you.
Thanks. Does anyone have any more questions?
I have a short question. I believe you have short example for the power round, right? Do you have example?
or the power round.
yeah,
I can definitely open up the whole PDF.
yeah. I just want to see how what it looks like.
Okay.
Yeah.
Um, so yeah, again, it's basically just teaching you something. So for example, right here, it's teaching you preferences and stuff, partial order specifically, also like indifference. So, oh yeah, also these problems in the power round, they each have points. So for example, 2.1 is only 1 point because it's easier than the other problems because problem 2.2 over here, it's 6 points. So yeah, that's also one component of this. And if we scroll down a bit more, some of the sections, like the sections vary, the questions in each section kind of vary, but they're still using basically the same area of math.
Okay. I mean, it looks like it doesn't look like a typical math problem, right? And not like algebra or geometry.
Yes, yes. Because these are more like higher math, I think. Oh yeah, because these power rounds are really different from the typical math competitions. Because the team round, individual rounds, and also the guts round, the problems are all just typical math competition problems and concepts. But in here, that's where it gets special. Yeah. Because it first teaches you something. It introduces you to a concept, and then it tells you some other things and asks you problems.
Oh, thank you. Thank you.
Does anyone have any more questions?
Can you briefly explain what's the in your example questions and you talk about the Basel sequence,
Yeah.
but I guess that there might be maybe people confused about this Basel sequence and harmonic sequence. But harmonic sequence doesn't converge, so maybe you can briefly explain what's the difference between them.
Oh, like how like harmonics.
Harmonic
It's
sequence.
like 1/1 plus 1/2. Oh yeah, because one of them converges and one of them diverges.
Yeah.
I'm pretty sure it's when the exponent is greater than or equal to 2. Wait. Yeah, I'm pretty sure it's when it's greater than or equal to 2 because, oh wait, it's greater than 1. Oh yeah, everything greater than 1. So, oh yeah, but when I was like looking at the problems here, I was actually quite surprised that they included the basal problem in here because I feel like it's also typically not part of like the concepts in competition math, but it's quite interesting. So wait, so what was your question? Like when what exponent made the harmonic sequences converge?
Okay, so I'm just curious, and
Oh yeah, for sure.
yeah, the Basel problem is already resolved, and then
Yeah, I'll just briefly.
anyway, it's not a question. I just want to discuss with you. Okay, no more questions.
Because I think your question might have been related to like when this sequence, like to the power of like k, right? When it converges.
Yeah.
Yeah, as I just searched up, I just had to confirm. I'm not.
Yeah, if k is equal to 2, this is Basel problem.
Yeah.
Then it converge, but at k equal to 1,
Yeah, k equals 1 diverges.
It's harmonic.
But then
Yeah,
when k is
diverges.
greater than 1, when k is greater than 1, it converges. Yeah.
Thank you.
All right. Thank you.
So
Yeah.
I have a question. So I wonder, do you happen to know that if I couldn't find any teammates around me in real life. Is it a common practice that maybe you can form a team online, like by calling people online and form a team?
Oh, oh yeah, I remember like last year, I'm not sure if it was SMT. I think it was SMT, but they had like individual people who wanted to um sign up with other teams. Um
But if it's an individual people, then when it's team round, was it like one against many people?
Not necessarily because you still need to form a team prior to the competition. Um, wait. One method is that you can, I don't know if you're familiar with the art of problem solving. There's like a community there.
Uh-huh.
Yeah, so for example, wait, let me just open it up. I mean, personally, if I didn't have teammates or like friends who are interested in participating in the SMT, I would personally go to the AOPS online community. I'll paste the link in the chat.
Mm-hmm.
Um, Basically, what you can do, you go to contests and programs. I remember
Mm-hmm.
someone asked something here, but they were asking for teammates. Um, so I need to find something real quick. Yeah, but I'm really sure I saw someone posting that they needed teammates for like some competitions, but I just can't find it right now. But you
I
can
got you.
definitely,
I'll try it offline. I think that's
all right.
that's good idea. Thank you.
Also in like other social media platforms, you can look for teammates. Yeah.
Okay. Thanks.
AOPS is usually like the way to go, I think.
Got you. Got you.
All
Thank
right.
you.
You're welcome. Does anyone have any more questions?
I have lots of question.
Yeah.
So it looks like this tournament is for middle school students and high school students, right?
Yeah, the
Yeah,
online one. The
yeah,
online.
online. Do you have any recommendation for, I mean, for grade 3 or grade 4 or even grade 5 students? I mean, any tournament or any math contest?
Yeah, for sure. So, I mean, SMT, you could still do it as like elementary school students, right? I mean,
I'm asking, do you have any recommendation for, I mean, for low grade students, such as grade 3 to 5?
oh yeah.
Yeah.
So there are a lot of middle school math competitions, for example. So if
Mhm.
I just pull out a list right here, there are good middle school math competitions here. I mean, I'm personally, so like out of these, you could just look at them, right? This one I really haven't heard before. I mean, AMC 8, like everyone knows about it. Definitely go do the AMC 8 because especially if you're preparing for the AMC 10 or 12, that really helps. And I mean, integrals I've heard of too, but that's only for girls. And math counts definitely, but you can't do that in elementary school. But you could prepare for it. MOEMS is really good. And Math League is decent. Mustang Math Tournament. Mustang Math Tournament. I'm also like a member of like the team in there.
Mhm.
There's multiple regions for it. And also, yeah, mathleague.org. But your school should have a math league, probably. At least in middle school. Yeah, so just a summary, AMC 8, integrals for girls. Um,
Math count.
yeah, math counts, but that's only middle school. Oh wait, but middle school, I mean, for elementary school, probably just AMC 8. I mean, Math League and Mustang Math Tournament, those three for elementary school students. Middle school students, a lot more flexible though.
Okay.
Yeah.
Can you please share this link with us?
Oh, like the AOPS link?
I mean, this link for, okay, maybe I can also search on the website of ALPS. This is the list of math competitions, right? Okay.
Yeah. I don't know why. Okay. Okay, here's the actual link.
Okay.
And
Okay. Thank you.
all right, thank you.
Thank you.
And Vivian asked in the chat, can you leave your contact info on Discord? Do you specify in chat or like here, like what that means?
Okay. I saw the message. Okay. Thank you. Thank you. Leave your
You're
contact.
welcome.
Okay.
Oh, like mine?
I think someone asking your Discord contact. Actually, I don't have Discord one, Discord account.
You're asking for like the Stanford what tournament? Yes. Yeah. But as I also just said in chat, like if you're asking for like a specific, all right, never mind. Okay. But yeah, if you could specify, you could still say it in chat. Does anyone have any more questions? Oh yeah, also in the slideshow here, here's the useful links. It's the overall SMT website. So the rules over here. Also like the past tests are really useful if you want to look at it. If you just navigate into the SMT website, you look at the sections up here, just click on past tests. It's really useful if you want to review for it. Does anyone have any more questions or is this presentation good? Does it answer all your questions? You're welcome. You're welcome. Okay, so I think no one has questions. So thank you all for coming. I am a new lecturer at Logistem, so it's been a great pleasure to present and provide this seminar. And thanks a lot for coming, everyone.
Thank you.
Thank you.
Thank you.
Thanks. If you're like busy and you want to leave now, feel free to leave the Zoom.
Hi, Kevin.
Yeah.
Can I ask you some question?
Yeah.
So, I'm just curious. So when did you find your interest in math? Um,
I'm pretty sure this is off topic from the SMT, but
okay,
I'm happy to answer it. I'm happy to
Yeah.
answer it. So, I mean, at first, I don't know, from elementary school, I was just I thought it was pretty fun. And I mean, I wasn't really like the best in my grade or something, but later, like growing up, you get more experiences and you're exposed to more math, and especially in middle school, I found my interest. And you don't really have to be really good at math. Like I'm not in like as good as math as some of the people I know. But just to participate in the SMT, you definitely don't need to be that good at math. I mean, SMT is definitely one component that could spark someone's interest in math, right? Because like like any of these college held tournaments are pretty fun. And especially if you participate in the SMT, it's surely a really amazing experience for you to do fun math problems with friends and people from around the world and stuff.
Thank you, thank you, thank you.
Thanks. No one has any other questions? If no one has any more questions, feel free to go. Yeah. You're welcome. Thanks for coming. If you want to go now, you can go, I think. Thank you very much. I needed that.
Good job, Kevin. Go, go, go.
Thank you.
Bye. Have a good night.
Bye.
Bye.
Yeah. And Melody, if you're here, Well, you could go, but yeah, I'll just stay in the meeting for now. Okay. Okay, Melody, if you're here, just feel free to go. If you're not here, I'll just leave for now. Yeah. Yeah, but feel free to go.